Hello, everybody. My name is Lionel Florit, and today we'll be talking to you about IoTDM. This project has been started a few months ago. I'd like also to introduce you. John Burns here is sitting in the front row, and he is definitely a key central figure in this project. Along with the other contributors here you see on the slide. Different companies, several people have contributed some code to the project there. So what we'll be talking to you about today is we'll start with an overview of the project. We'll talk about IoT middleware a little bit to just fit it in the context of IoT to define what it is and what it's for. And then we'll talk about the software components, the plugins, and the security. If you have any questions, feel free to raise your hand and we can have a discussion about this. So the project IoTDM has been started in December 2014, and the goal was to basically write an application running on top of ODL. We don't use ODL as an SDN controller. We use it as an application development platform. So the application running on top of it uses the components of ODL, but it's not an SDN controller. It's based on 1M2M, and we picked that standard because at the time when we started the project, this was a fairly the most mature cloud IoT specification we could have found. So basically, we have the combination here of an open standard on top of an open platform. We started by supporting a basic set of features, and this is good enough for you to deploy IoT applications. We don't intend to support everything in the 1M2M spec, which is gigantic. The first time we delivered the first phase of the project was in the Lithium release, and here you have a pointer to our project page. So here is the overall architecture. We try to use as many components, reuse as many components of the ODL platform as we could. So we have our IoTDM application. We reuse the in-memory data store. We use the MD cell. We use the plugins which were present already. And basically, it is designed to aggregate data from things and expose them to IoT applications. The data I'm talking about are the actual measurement of things. If you have a temperature sensor, the data I'm talking about is the actual temperature that we're getting, the value of the temperature. 1M2M can do much more than that. It can also do, it has some management aspect, but we have focused on the data collection portion. So in principle, all the things will have an IoT application. So the IoT application deals with the physical world. So if you have a thing that is designed to interface to sense pressure, so the application will report pressure readings in a digital format. And then on the device, you have some sort of stack, an IoT stack that provides you with an adapter, a serialization protocol, some security features maybe, so OAuth, TLS, DTLS, JSON, some sort of encoding. And with all of that, you communicate with IoTDM as the data collection platform. Northbound again, IoT applications gather the data and basically use it and make it an IoT solution end-to-end. Something else we do support, something else we support in this release is the federation. So the federation is the ability to have multiple ODL instances distributed across the network and connected to things. And so you can keep the data at the edge of the network if it's not used. In IoT, a lot of data is produced and very often useless. So it makes sense to have this sort of architecture where you collect data at the edge, and if you want to export the data to the infrastructure node, mothership on top, then you can do that. And 1M2M has some provisions to allow you to design, to tell which resources should be shared northbound. So which IoT problems we want to address? Well, basically, when you construct an IoT solution, it's usually a collection of things that have nothing to do with each other. So an IoT solution may involve a light bulb and a printer and a fan, and all of them brought together, they do your solution that you're trying to design, the problem that you're trying to address. But the issue is that the company which made the bulb is not the same one that made the printer, and they were not designed to talk to each other. So one of the things that we are trying to solve here is to expose the data of those different parties that have nothing to do with each other, bring them together in a central place, and have this data available for IoT applications to consume. So the IoTDM is a data repository with RESTful interfaces on the southbound and the northbound, and you basically interact with it using the CRUD and verbs. So very quick background about 1M2M. As I mentioned, this is the standard that we picked when we started. It would be interesting to support others, and we'll see as volunteers come up, maybe we'll do that. 1M2M is a collection of several SDOs which realized at some point that they were working on the same thing. So they decided to get together and merge and create this standard called 1M2M. So it's basically an horizontal architecture, meaning that you are supposed to be able to apply that to any domain. So if you have industrial or smart cities or any other verticals, it should work across the board. RESTful architectures, all entities are represented as a resource in a tree. And so an application is represented as a resource, a device, a data group, access control lists. This tree of this IoT tree holds everything you need to create your solution. Each resource has some set of attributes, and what those attributes are, they will tell IoTDM how to manage this tree, because if you accept the data without any condition, at some point you'll bubble up and you'll explode. So there are some rules that you can associate with the resources, and you tell IoTDM, I want to keep those resources for a certain while, I'm going to recycle those resources, I don't need to have more children for this specific branch of the tree, and so on. The tree representation is standardized, but it's not, the implementation is not. So you may have a, we decided to use ODL as the underlying functions, but you can represent the tree in XML or Yang or Hadoop, it really doesn't matter. So this is an example of a 1M2M tree. So here you see the root on the left, a container, and a content instance. So 1M2M has defined some set of resources. Some are generic and some are specialized. The generic ones, like the container, can hold any type of data you want. Some more specialized resources, like the management command or the location policy, those are really targeted to address a certain need. And they have attributes specifically for that. So you'll have longitude, latitude, for example, in the location resource, whereas in the container resource, you have just generic fields. The bubble, the rectangles with rounded corners, those are attributes. So this is our examples of attributes where you have the creator of the resource, the maximum number of instances that you want to keep. So this limits the number of children. The maximum byte size, so you can control the size, you can control the age, and so on and so forth. On the right-hand side, you have the content instance. So this is a specialized resource. This one holds the actual data. So when a sensor reports a value, every time the sensor reports a value, there is a content instance created in the resource tree. So you see the number of children will grow as the samples come in. There are some interesting attributes in that content instance. For example, one is ontology reference. So a device may add additional information to the data in order to tell the consumer of the data what the data means in a context of an ontology. Or you may also have some meanings like the semantic explanations that tells the consumer of the data how to decode the data. This is an example of a resource tree. So basically, when you build an IoT application, what you'll do is you'll organize your data into a meaningful way. So this is the skeleton of an application. So the IoT solution designer will prime the tree by putting in the objects that fit in his context. And those objects here are represented on the GUI here, which is an addition to this IoTDM release, where we are adding a GUI management to visualize that. Now you see on the left-hand side, those are the attributes that 1M2M supports. And so those attributes here, so these are the attributes that I was showing you about, telling you about, and we have added tooltips here. So if you hover the attributes, then you know what they mean here, and this prevents you from reading 300 pages of standard. So it's quicker to do it this way. All right. So now, once you have collected the data in a place that makes sense for the IoT solution, on top of it, you build applications. So this is an example of a company that has 1M2M gateways, and they do patient remote monitoring. So with their solution, you basically put your finger into some sort of reader, and they report your tension and your blood pressure and those sort of things. So the gateway is connected to the little things over Zigbee and turns around, sends 1M2M messages back to OpenDaylight, and this dashboard has been created on top of that. All right, so now let's talk about the plugins. So who is from China in this room? You're from China? Do you speak Mandarin or Cantonese? Mandarin. Unfortunately, we cannot talk to each other because I speak only Cantonese. So, so this is my favorite joke, but this is very representative of plugins. So in IoT, the problem is that you never get the right protocol on the other side. Even if you tout a standard 1M2M or others or IC or lightweight M2M, you never get the right protocol on the other side of the connection. So you always have to adjust. So let's see the different situations we are faced with. So at the end of the day, you have this configuration. You have a client. So this client is very generic. It could be an IoT management station, or it could be an end device or a gateway. It doesn't really matter. So in this client, you have an IoT application, you have a device plugin, and you have some protocol bindings of some sort. The middleware side, this is us. This is IoTDM and ODL. You have also the protocol binding. You have the plugins, and you have the IoTDM core and the data store. The payload here you see is a 1M2M payload. And in fact, if somebody wanted to be part of the 1M2M family, this is enough. So if you have a device that can generate a string that looks like this, then this is enough to be 1M2M compliant. Actually, you can even generate less than that because the foo on the right-hand side is the resource name. So you could actually generate just the M2M : sin con some data, and close brackets, and that's it. So that's all it needs for a device to be OneM2M compliant, plus some headers that you add in the CoOp and HTTP. So this is the situation where that's the easy situation. We have the client supports OneM2M, and we are OneM2M, but the reality is usually different. So mostly this is going to be the picture that people will be faced with, where you have a client that you cannot modify and you cannot put a OneM2M stack in it. Even if the OneM2M stack is very trivial, it's not going to be possible. So you have a proprietary device plugin, you have a proprietary protocol, and you have a proprietary plugin on the other side. We've been faced with that situation actually with, in my company, we wanted to connect to routers, and of course we couldn't make our routers OneM2M compliant. So we communicated with SNMP. So we reused the SNMP plugin of ODL to communicate with the routers. And we had a plugin that's collecting the SNMP payload, turning it into a JSON OneM2M structure and writing this into the resource tree. So writing plugins has become much easier thanks to our friends at Technicolor and thanks to John here. So if you want to write a plugin, basically you specify the protocol you want. So today we started with HTTP. We'll support CoOp fairly soon and MQTT. Those are the three, by the way, that IoTDM supports. So you pick your protocol, you pick the port you want to use to receive the traffic. And after that, you have a set of methods that you can use to interface with the resource tree. So you get access to the payload of the data you receive, and then you invoke the OneM2M methods to write things into the resource tree. So this is your translation. Of course, you can include in here any type of code. You can even shoot the data out, and so basically the data may come from devices and may stay 50 milliseconds on the platform and being redirected somewhere else. So unlimited possibilities here. You can really do whatever you want inline. So some ideas of cool plugins. We're currently working on the OIC interworking plugin, and I'll show you in a minute how this works. But basically, OneM2M has a standard for lightweight M2M interworking. When you have a standard, it's very convenient because now you know which resources on one side have to be mapped to another set of resources on the other side, so you don't have to think as a developer. But if you don't have a standard, then you can do it. You just use your common sense. It takes a little more effort, but it's totally doable. So OIC, then also you can interface with TSDR. And we have a TSDR project at part of OpenDaylight. So you can interface with that. You can publish to other IoT cloud providers too. So that would be an interesting question. Why would you want to interface with a cloud provider if you had something like this? Well, the reason is simple, actually. Let's say you are the IoT chief of your company and you deploy an IoT solution in your company and you have 10,000 IoT devices throughout your company. And you pick an IoT cloud provider to host your application and your data. That's usually what happens. And then down the line, you're not happy with your cloud provider and you want to change. So what do? You have to go back and revisit your 10,000 devices to change their stack so you can switch to another cloud provider. This is the master lock-in that people get into, and yet nobody really fully appreciates the impact of getting into business with one cloud provider. So here, what you could do is you could have on your end a standard compliant or OneM2M or OIC deployment, and then you can reformat the messages and export them to your favorite IoT cloud provider. You want to change IoT cloud provider, you change your plugin. You don't revisit the 10,000 devices that you have deployed in your walls or in your ceiling. In terms of OIC interworking, that's what we've started doing. So you have a provider in ODL Parlay, where this provider is our plugin. It's an OIC API client. And this plugin acts as a client to the IoTVT OIC server. So this client will get the data and browse the OIC server, retrieve the data, format it, and map it into the 1M2M resource tree. So basically sending GET.
What is this southbound CoAP protocol?
Southbound?
CoAP.
The CoOp?
Yeah.
So CoOp is the moral equivalent to HTTP in the device domain. So HTTP is very inefficient in terms of encoding and number of bytes used, but CoOp is the moral equivalent for small devices to communicate like HTTP. It's the equivalent, the moral equivalent. Thank you for asking.
There's an RFC for it, and it's a UDP-based protocol.
Oh, okay.
You can encrypt what you run on top of it. But from the CoOp perspective, it's like HTTP. You may encrypt on top or not.
You can run CoOp over DTLS, which is good as well.
Yeah. I'll talk about security in a minute. So this is what how you interact with the OIC server. You send GET requests. So the plugin. This starts from the plugin. Plugin browses the OIC server, gets data from OIC, gets a JSON structure, now does the mapping. If there is a standard, then it's helpful because now you know what to do with this payload. If there is no standard, then you figure out yourself, and then you write this down into, on the other side, onto the IoT data store. So if you want to contribute, you're welcome to contribute at any level, basically. So this is, that's the message. Now, about security. Here is how security works. We paid attention to security because security in IoT is a big deal. So the security procedures goes like this. From the left to the right, when the device comes up, it has to register with the network. So you have a first barrier. You identify the device. So device, it could be your cell phone. When the cell phone comes up, then your service provider authenticates you. So this is the type of authentication I'm talking about. 822.1x is an example of that. So you authenticate the device, then you establish an end-to-end tunnel, encrypted, so TLS or DTLS. Then after that, once you have established an end-to-end tunnel between IoTDM and the device, I keep saying device, but again, this is a generic term. It could be gateway. Then once you have this channel, after that, you establish a connection and you verify if the device is known. Do you know this device? Has it been provisioned in IoTDM before? If you know the device, then you check if the device has a valid token. So we have plans for OAuth. And therefore, every request you can check if first you know the device, and second, if the token associated with the request is valid. And if all that passes, then you have access control policies check. I have a badge to go into my company building. It's not because I can get into a building that I can repaint the walls, right? So once the device gets into the system, if the device requests to delete something, we have to make sure that this device is actually entitled to do what it's asking to do. So this is the last stage of the security check. Another way to see it is through this diagram. It's just a different representation, but basically it's the same thing: access control, encryption, authentication, authorization. Unfortunately, we don't have a lot of time to go over the details of the security procedures. We only have 3 minutes left in this presentation, but I will upload those slides, and you will have them with call flows, which explain what happens when a device comes up and the information exchange and how this whole thing is set up in a secure fashion, and examples of access control policies, which tells you who can do what and under which circumstances. In conclusion, ODL has proven to be a flexible application and platform for IoT. It was first released part of Lithium, and it brings IoT data awareness to an SDN controller. You're welcome to join and write plugins. It's really fun to put things together. Thank you. Questions?
Do you have any working demo or something like this? You can see?
Yeah, you can actually. I don't know if in the booth we have that, and at the Cisco booth, we don't have a live demo, but at our project page, you can download an image and you can build it, and you'll see in action.
That is in GitHub?
Yeah. So if you go to the IoTDM project page, you'll see instructions on how to. You can run it on your laptop, no problem.
Okay, thank you.
So it's one of the sub-projects of OpenDaylight. So OpenDaylight has an IoTDM project, so it's got its own page, it's got its own project, all the software is there, you can download it and run it.
So is it available as a forum?
Yeah. Just download master, you build master, and you'll get all of this.
Question.
Yes.
About resource consumption, how much memory are you consuming? Given all the data, what do you need to get IoTDM running?
Up and running. Well, we tried to squeeze it, and the best we could was to run it on a Raspberry Pi. Now, it's not really fast, and as you said, you don't collect that much. But it's possible. Because IoTDM comes naked in terms of, ODL comes naked with IoTDM,
Right.
if I may. So there is not, all the rest is not included.
Do you put the data store on an external drive or?
Currently, it's the in-memory database, so the same data store that OpenDaylight uses. All right, thank you very much.